Hey fellow cheap night vision enthusiasts, so what we're going to do is build a night vision goggle kind of digitally, and it's not real night vision. So that's the first preface. I mean we all know this taking a look at it, but maybe if you haven't bought the parts, you haven't started, just remember this is obviously not real night vision. This is essentially just looking through a camera and using infrared 850 nanometer wavelength lighting. So first thing first, to get started, you're going to want to go check out my guide, because that has everything on paper for you. That has everything you're going to need to look at, and that's actually what I'm going to read off of right now, just to make sure I get everything right, because there's a lot of stuff you guys need to get right when doing this. And for that reason, I made a Discord, and the Discord's great because you can say, hey, anyone had luck with this supplier, and have luck with this supplier? No, yes, absolutely don't buy this. Please buy this. It makes sense. It'll save you some time, whatnot. So first things first, I have a lot of parts here because I do this. This isn't my first rodeo, and if you're coming here from general purposes YouTube videos, good for you. This will definitely help you out a lot. Now to get started, first thing you're gonna need, and I say first thing because this is the most important, is an OV7725 camera module. That's that right there. Do not think that the OV, I think it's 2640s that come stock with these on Ali and Amazon, do not think that that will work. It will not. So OV7725, get those. For my design, and I believe general purposes design, the little ribbon cable variants are perfect. So try to stick with those and you'll get somewhere. Next thing is obviously an ESP32. Definitely check the Discord, or at least the parts list in the guide, because there are several variants. These are made by thousands of different manufacturers, so they're all very different. And I've actually had issues. This one here, I actually have issues with. These ones I don't. That's why I brought several. This one is essentially just a prop. And you're going to want the ESP32-S, and that's the cam model. So it has that ribbon cable attachment. Next thing is your LCD. And this is essentially just a watch screen, and it just has female pinouts. I have to redo these because I soldered them like a moron, thinking it would fix an issue. They actually did fix the issue, but now I'm going to adapt it to a new one, so I have to unsolder and do a whole bunch of other stuff. But LCD, it's a nice little watch screen. If you're going to be doing general purposes clamshell design with the quad nods, be very careful when closing the clamshells, or else you will tear the ribbon cable right there. The little tiny power ribbon cable, there's data and power. You will tear that if you're not careful. So be careful when you're closing the clamshell, or else you'll have to wait another month or two for Ali to ship these back out. Next thing, which you have to kind of be selective about, are these Google Cardboard lenses. And the exact specs of these are 34 millimeter, that is the diameter. Then you have the biconvex, which is the property of the lens. And then you also have 40 millimeter focal length. That's the distance to focus on a LCD screen, perhaps. So that's the difference between distance between lens and board. You can get away with the 45 mils that are all over AliExpress, I believe. But if you have any issues, just go get the 40 mils. They're harder to find, and you usually have to buy them in batches. But good luck. I believe you can find those. And then I guess the next thing you need is either a way to power it. So you can either go with a like a buck converter, like a DC to DC step down converter from Ali or Amazon. Just step down like some crazy voltage, like a battery pack, like 12 volts or something, and step it down to 5. Or you can just be kind of like jerry rig stuff like I do, and this is just a USB 5 volts to a power plug, and I just power it with a USB. But I will be revising this, since this was to my quad nod variant, and I'm going to be redesigning for my Cyclops variant, which is this video. So next thing you're going to need is an FTDI programmer, which I don't have any on here because I'm not programming, but in the next segment where I switch over to programming, you'll see it there. It's the red one, and I'll show the part and whatnot. So I believe the best course of action now is to go to the programming video. You're going to take your ESP and your FTDI and maybe hopefully a breadboard, and get this thing programmed, and then we'll cut back to this. Hello everyone, today we're going to do the programming hardware aspect of the night vision goggles, and essentially what we're coming from is General Purpose. I don't know what he changed his name to now, but General Purpose had a fantastic, he's a brilliant guy. He made a batch file, and essentially all we're doing is piggybacking off of his software to our hardware design, at least our 3D print design, because I believe there was a couple issues with the way at least I implemented it and a lot of other people are implementing it. And so essentially this will resolve, I've probably repeated myself, but this will resolve the kind of your eyes pointing the wrong direction, if you will, because we're eliminating all the cameras down to one camera, and that's where the Cyclops name comes from, if I haven't said that already. So step one will be obviously the hardware aspect of wiring it up electrically. So I believe I have these two cameras in sync. So we're going to go ahead with it, and I'll throw a little wiring diagram up on the screen. Essentially, you will be just wiring your FTDI programmer, which you should already have, and you should essentially troubleshoot that already, because a lot of issues will come from that if you don't do it right. But that's this project. There's a whole bunch of issues you got to resolve yourself. Well, what you're going to do is of the ESP, you're going to go of the UOT or the U0T, that's going to go to your RX, your UNR, that's going to go to your TX, your 5 volts goes to your VCC, and ground to ground. I'll throw some diagrams up on screen. You'll see I got a nice table one, which will probably be on there already, and there'll be a really nice one made by someone other than me. Nice wiring schematic. You don't have to do it that way. A lot of people just do it this way with a bunch of male-to-male jumper wires and a breadboard, but you're obviously free to do it however you like. So next step, here we are, is going to be actually wiring that up. What I like to do is I have my breadboard on this side, and I have it bottom out, so the pins are at the bottommost, so I can't really screw it up. So the pins are at the bottommost of the breadboard, and then there'll be the program on this side, and then on the other side you'll see a screen hooked up so we can test it. This is a problematic ESP I have. That's the because all mine are soldered in, so I actually have to use this one. But this one will work for our example, and it should behave kind of identical to at least what yours will. Alright, so we plugged it in. You probably should be plugging stuff in with power on, but that's the way we live. So I'm going to unplug it for now, just so my computer doesn't. And you probably heard the little desktop audio USB disconnect. And I'm just going to double check to make sure this is all plugged in properly. Looks like we are. Looks like we got, yep, 5 volt ground. There we are. You'll see I got some more diagrams I'll throw up on screen. And I'm also following along with my guide, and if I update anything here and it's not going to make the video because I update it later, the guide will show the most recent version. So next thing, we're going to go down a bit in the guide. Now we're going to go to software. Alright, now we got it hooked up, we got it electrically disconnected via the USB. So the first thing we're going to do on the computer is launch up your device manager. And what you can do with that is open up your port view. So you can see on here, my 3D printer is on here right now, so it might be problematic. That's the COM10 port. And I'm actually printing right now, so if you hear some little servos or whatever, the steppers in the background, that's that. So it's currently not connected, or at least the FTDI is not connected right now. So what we're going to do is connect the USB. And there we are. We have our COM6 port is the newest one. So that will be what we'll be targeting when we launch up this flash tool. And the most important thing about these flash tools is obviously to get the one that's going to work at all. But the biggest issue we're having right now, at least in our the community we've developed on our Discord, is Espressif broke their software in version 3.9 I believe it was, yeah, 3.92. So this one doesn't work, in fact. At least you experience more issues. And what we're going to take a look at is obviously just launch up the flash tool. And we're going to change that to ESP32 because that's the board we're working with. So good luck if you're working with something else. We're just going to minimize a couple things that we don't need, just for everyone's sake. And I already have this screen all set up for me because I've done this before, actually dozens of times. But what you're going to want to do here is go through with, we'll do this in order. You're going to find your file, right? You're going to go to General Purposes Thingiverse account. I'm going to probably do some pop-ups on screen. You're going to go to his Thingiverse account. The link is in the guide, and the link is also on our Discord. You go there and you download his binary files,
which I don't have the software capabilities or know how to design those or even to reverse engineer them. So you're going to have to just grab those guys, grab his files. There's a right eye and a left eye. Let's see. Yeah, I didn't dox myself. All right, yeah, so there's a right eye and a left eye, and you can load both of them in here, but just make sure only one of them's checked regarding to whatever one you're flashing. You're going to set your offset, and make sure you set your offset to 10,000, not 1,000, not 100,000. Set it to 10,000, 0 by 10,000. Set that. It'll turn green, and if you had that little prompt up, I minimized it, but yeah, if you have this little prompt up, it'll say, it'll tell you the test offset in the case, okay? So we'll keep that up, actually. And yeah, every time you click off the screen, it'll re-verify. So what you're going to do is do 40 megahertz, and you can click back and forth between these because actually we've experienced some issues where for some reason it doesn't set it, but feel free to just leave these as is unless you're experiencing issues. And these are about the settings you're going to want to do. Just make sure your COM6 is good because that's what we are right here. And then set your baud rate to this exactly, 115,200. Try not to run it higher, try not to run it, I don't believe you can actually run it lower, so just keep it at that. And go ahead and hit start. And you'll see right here, it's doing this stupid thing all the time. It does this all the time, right? So you're like, oh, it's not going to work. It's something's bugged, right? So now what you're going to do if it's doing this repeat connect baud, you literally grab the USB cable, unplug it, and plug it back in. Give it a second. And will you look at that? Good thing we had both these cameras synchronized. See, and there you are. You see it finally connected, and the progress rate is going up, even though there's kind of like there's no indicator showing it's in process. It'll go through here. It'll say finish. It'll say all this info, and I guess you can verify the bytes to make sure it's the same thing. If you're going to do more stuff, or at least you're going to work on your own thing, maybe have them like Wi-Fi stream video somewhere. Those are your IDs to program in your own on your own time and do your own thing. But this board is ready to go. So I'm just going to scroll down farther in my guide here on the left to make sure we're following along all right. And so here we are. We got a wiring diagram for the LCD screen, which I went over already, what part that is and whatnot. The LCD screen to the ESP32. And what's great about this little breadboard I have, we'll go back to the breadboard view. I'm going to unplug it because that's the safe route to do everything electrically. I'm going to undo this ESP from this side, bring it over to my testing side. We'll just wedge it in here. There we are, bottomed out on the bottom, so we know where we're at. You guys can see the screen. Make sure that camera's pointing in a security safe direction. Grab our USB extension, plug it in. We'll see what that LCD says, and there you are. Look at that. You got a view of the wires right here. So I'll even give the camera a little bump to make sure you guys know it's alive. And there you are. So now you have your throughput from your ESP to your little cam. From your cam to your ESP to your LCD. And now to move on to the hardware installation aspect, which in the guide I believe it's called assembly:/hardware. So we will go back to the bench.
All right, now we're back, and this is what we're going to build. We're going to either build the dual model or hybrid model based on what you choose. Hybrid has one eye, or one cam instead of two cams here. Or you can build the mono, and honestly this is my favorite because it's the most minimalist, it's the cheapest, and you're not going to run into any issues where your cameras are pointing very, very minimally different directions, and it kind of screws up everything because your eyes are essentially bug-eyed. And that does get me a little thrown off in terms of needing to be kind of locked in that situation. And obviously I had the same issue with these. I couldn't really get them dialed, even twisting them relative and pointing them, and that's a great design, and that's fantastic, and honestly very well thought out in every regard, except really the ability for a bunch of people to replicate it easily. So I don't know, this isn't really any different than that. It uses the same parts, the same software, the same everything, just in a little bit different of a package. and you can choose kind of if you want modular or dual in this case. And here's a quick demo. This one is basically a completed unit. You can see I got a switch and a little power plug here. Cameras are installed, lenses are installed, and I will be going through making this in a quick second. So this is just running off of a 5-volt USB battery bank. I would suggest using higher voltages. Turn that on, make sure that's on, and give it a second. And bingo, there you are. So we have air quotes night vision if we were to strap a camera on it. So get that pretty close in there so you guys can kind of see what you'd be looking at. It doesn't look this bad in real life. Just kind of two cameras going through each other doesn't really like, but yeah, this works great, and they're barely pointing different directions, so if you kind of got a tolerance for that, you can survive it. So I guess the only thing about this is when you're flashing, I believe the left eye is the left eye and the right eye is the right eye, at least when it comes to software. This, it's the opposite. If you want to mount the right eye, you can see since there's an offset here because the board, there's an offset due to the board not being perfectly centered on the camera. So this is your left eye is your right eye and flipped in software. So if you want to make your right eye, which is the only variant I have right now until I mirror it back over, you would flash this with the left bin file and then install it. So I'm going to tear this down and get started. All right, so ideally you got all your parts printed out and you have your list of screws. Now I would advise first checking the guide to make sure you got your right screws before starting and whatnot. So what you're gonna need is your ESP and OV77025 camera flashed if you're doing the right eye, aka this will be positioned like this with the mounts on top and the overhang on the right. If you're doing a right eye, you're gonna need the left flash. So flash it as if it's a left eye, and you'll be good to go. So first things first, when it comes to installing these lenses, is obviously converting the camera to be able to see infrared light. And this one's new. I have a whole pile of them with them removed already just from various other projects. And what I'm gonna do is pop the camera out, and you have it right here. This one still has that little cover on it, and what you can do is take note of the kind of the exposed threads or the amount of exposed height there. And then what you're going to want to do is grab this part of it with any type of wrench or channel lock. I just like these channel locks because they got some teeth on it. Grab onto it a bit and just give it a little twist there. Oh, sorry, it wouldn't focus. Give it a little twist and it'll crack the little glue there. And just kind of remember how many threads were exposed because you need to put it back to that focal length. So you'll just unscrew this here. What I like to do is kind of have it upside down so don't get any glue debris inside the actual lens area. We'll put it down. And the next step is you'll see a little reflective thing in there. That is the IR filter. So I'm actually going to grab a knife here because I didn't have it ready. Take just a tiny little knife. This one's kind of beat up. And just reach in there and crack it and break it and extract it somehow, you know. Just take your time and don't go too crazy and I don't know, break something more. I'm gonna get a little better of a knife maybe. This isn't better, but give it a shot. Just a little bit of grab in there, maybe it'll break away. There we are, we got the crack. We'll just dump some of it off to the side. There we are. Just essentially removing that. And it's pretty simple. You can't really go too crazy with it, and you're good to go. So all you're gonna do is bring that back over, put it on, try to make sure you don't cross-thread it, get it to click, and go for it. Kind of threading it back to where it was. All right, I'm one thread off. And there we go. So now you have your IR removed. So you got all your parts here. You got your lens, your LCD, and ESP, some wires, or at least your harness. Mine's a little beat up because I've soldered it so many times. Yep, and you're good to go. So you're gonna take your tube, which is one of the printed parts, and you'll see a list of all the right screw lengths in here. I don't actually remember a lot of them off the top of my head. You're good to go. So 3 flap lens. Check the guide. Check the Discord. And then here we get to go. Just make sure it's really clean. Drop it on in here. You can see this one's been cut from on that project. So we'll drop it in here. I like putting the most bulbous side inward. Press it right on in, and you actually shouldn't have too much of an issue there because it's a little oversized. And then next step is taking your lens cap, or I think it's just called, yep, tube cap, and screwing it in. Just got a couple little tiny M3s there. Just send them home. What you're gonna do is essentially make a thread using the screw, and then depending upon your printer, we'll just kind of see how well this goes over. But I've kind of run these screws back and forth a bit, establishing some threads, and I'm able to actually screw it in and lock it down. Like actually screwing tighter locks it down for my design, rather than just stripping the threads out. So we'll send this one home as well. And you see there's very minimal gaps in that there. And that's just gonna retain the lens, keep it from coming out. Next step is taking your plate. It's pretty simple. Got your LCD, drop it right on in there, and you'll the brass will kind of tolerance with that based on your elephant foot of your printer, and just kind of ease it on in. Should click decently right on in and be kind of retained by the brass pushing on the material there. So this, as you can see, won't fall out. And give this a nice quick clean as well. You could probably not use your shirt. You could probably use something else. Maybe a microfiber. And there we go. We got a relatively clean lens. I say relative. All right. And now what I like to do is imagine it as if it was installed. And you can clock your lens bolts here, so it kind of looks nice. Nice and one on top, because you can clock it weirdly and it would be all staggered, but I think kind of the pyramid one on top looks great. So you can send these ones about halfway through. I like to do it just until they poke out, or at least poke your finger, so you know they're ready to thread into the next material. You're going to want to kind of thread these, make sure that gap's as small as possible. And there we are. So we get them all kind of poking out there. And next thing we're going to do is move over to the case here. And what you're going to want to do is take your link, get an M3 nut, make sure it's installed in the pocket there, and then pocket in your M3 nuts in there. So you have your M4 in here, M3 in there, and slide that on or drop it on, whatever keeps the M4 nut in there. And then you're going to send home these M3s to their respective holes and fasteners. Kind of maybe hold the nuts in there so they don't pop out the back. And you can really tighten these down if you want to close that gap up, and I'd suggest that to kind of make this fastening as good as you can. You can hear the M4 rattling around in the base of there. So we're good. So now you got that link attached. You have your lens module and case thing. You're going to take your cam and ESP. What I like to do actually before I install them in here is, this is an OV 2640, so it's not compatible. So to me, I have so many of these, they're basically junk. I like to kind of make sure that hole's all nice inside there, kind of level, because that kind of determines your camera direction pointing out. Make sure that the surface is all flat. And take your junk camera, and it should just kind of press right in there. You can see mine pressed in there all nice, and then just on the other side you can just pop it out. And that's just to make sure when you go through to go do that with your OV 7725, you won't kind of put unwanted stress on it in breaking it. All right, I took some time to wire this up off screen just to save some time here, and this is what you're going to do. Essentially follow the table, run corresponding codes on that to the corresponding codes on that, and you should get there. What I got is these little jumper wires just running off the back here. I guess their length. What you could do is just solder correct red and black in there and make them all the right length. But I think this should be close to what I'm going to go for. I have these marks in here because I've soldered these so many times, or at least it's been so many different designs. So I guess first things first, make sure your camera is actually seated in there. And a good way I found it is just to hold the wires when doing this. You're going to want to hold this and just kind of go straight into where it would sit with the ESP, and the camera kind of auto homes itself. And there you can see the camera's in there, get a little push, and we got a good positive click in there. You're going to want to keep applying force, hold it square to the hole, and I kind of don't want to let that weight of these wires mess it up. And the orientation of the ESP at this point doesn't really matter, so you can just drop a bead of hot glue wherever you want. I'm going to try to keep it as square as possible just to make it easier on myself in the future when troubleshooting issues. This hot glue will pop right off if you really need it to. Don't make fun of the comically long hot glue hanging out from here. It's the only thing I got. Just put a little glob there just to hold the board from popping out. And I want to put another one on the other side, but I want to do it carefully without jostling it the amount I just did. There we are. 2 little globs, mainly just sitting right on the outside of the PCB, trying not to touch any components or whatnot. Maybe I'll even act a fool and push it into place. There we are. I got pretty close. Let's hold it there for a bit, and I'll cut back to save you guys some time. So now that our hot glue is dried, or at least dry enough, I'm going to attempt to snake these wires through a little hole I provisioned in the side of it. If it doesn't fit, feel free to make it bigger with a drill bit or whatever. I didn't exactly take its placement into account, but okay, perfect. Yeah, and there you are. You got one. See if we can get another here. It should be the right size. And again, stuff never really is. Might be worthwhile modifying that for the release, but hey, it's definitely going to be pretty hard to have water go in there when it's pretty close to the exact size. Yep, not impossible, just tedious. So I'm going to pull that a little tighter. Don't want to make it too tight on there. Should be good enough. Next step is to, I guess, plug in the screen. And what I want to do before taking the effort to seal it all up is to make sure everything still powers up and works. So I got 5 volts over here from an FTDI board because I don't have a plug yet. I'm just gonna pull the 5 volts over here and throw one on ground. I'll move that for you guys. Here we are. Throw 5 volts on ground, or ground it, and then throw 5 volts on positive. And there we are, look at that. I was scared for a sec because he was facing the ground. Let's see if these, hopefully those don't short when they get closer. There you are, you can see, you can look around the same area you just were. Cool. So now all we're gonna do is seal it right on up. So I'm gonna pull these power. And maybe put a little twist in there to help the wires go into where they need to go. And a little shove maybe, and there you are. It's all nice and closed up. I'm gonna take the time to press down while screwing in these screws because they're going through a lot of material at this point. There we are. Honestly, I'm happy with that. It's tighter than that model. So you can hear that M4 slotting around in there. So, and this, I'm pretty proud of this aspect. Mainly because it was very easy to do. This will directly bolt to this, your original general purpose designed quad nods. This will go right in about there. If you have a really wide head, you can see how this could be beneficial because you could pull that eye like comedically far out. I found most of the average eye is about 70 mil apart, so you'd end up locating it about right there. So I made a cut down variant, and this is it. You can see it's significantly cut down, probably about half. It's the exact same design. And then you can just click it right on there. If you have around, as I said, 70 millimeters of eye distance from eye center to eye center, this should get you there, because there's about, I'd say, 2 mil in each direction. So for most people that should be good, but if you got a bigger head, I know I got a pretty big head, so I might have overdone it at 70, but good luck. And we got an M4, just like General Purposes design, and it'll go into the M4 nut in the base. And there you are. You got your night vision setup, and I guess we can pass these through just like his design. All right, and this will bolt straight up to the normal beam that he had designed for my model. I mean, it'll bolt up exactly. This is my helmet. You can see I got a infrared flashlight. This you can just flip right over, shove your M4 nut in there, flip the beam, and it would bolt directly to here, and you can pass through your, I guess your wires would be to your port right there for power, and it would attach right to the side. So it would be exactly in design to the similar models of that one, and a lot more that I hope people will make in the future. So you can see that'd be pretty nice. You got a single eye, so you don't have to worry about the issues of, I guess, your eyes disagreeing. I would suggest pulling this flashlight over to this rail on this side to counterweight it, and I think you'd actually get pretty close there. So I guess the last thing is to make sure we didn't break anything in installing it. So let's bring back power. Ta-da! I've had some great luck today. Give you guys a look. And there it is. I'd like to interject with an example of what it would look like when done. So these are the dual models. This is in more or less complete darkness. And I got a infrared light on my helmet. And we'll just look around here. Here, I'll commute. It's really hard to hold this. But there we are. You can see there's like a couch. There's a table. Take it away. Ready? Nothing. So we'll bring that back. You can see the refresh rate's pretty good. There's a little bit of artifacting in there. And you can see my shadow from where I'm holding. But yeah, this thing's great. Well, that's the left eye. It's the right eye. A little bit of artifacting. No biggie. I wish you all good luck. And as always, if I haven't plugged it enough, please check out the Discord and the guide. If you have any questions, the guide or other people will have definitely experienced them, and it's definitely on there. If it's not, I'd be surprised. Feel free to ask, and that's even all the way down to parts, because I know a lot of people have issues. For example, stock ESP, stock OV2640, no, they won't work for that bin file. Various issues that people have already troubleshot. Black screen, if you get a black screen on boot up, like it flashes the white screen, gets a black screen, usually your cameras. So you can run all these issues through our guys, and they'll definitely get you somewhere if you're clueless. But at the end of the day, it's usually part issues, because they are made with a very, very wide tolerance of acceptability. So, good luck, and as always, keep inventing.